Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to today's lesson on the use of cumulative frequency curves. In our last lesson, we learned how to compare two groups of similar data by determining their consistency. Today, we will learn how to determine the dispersion of data and the variability of its values by using cumulative frequency curves. Are you ready, students? Let us begin the lesson. Students, you probably recall frequency curves from our studies earlier in the unit. The shape of a frequency curve describes the distribution of a data set. A frequency curve can have a shape that is symmetrical, skewed to the left, or skewed to the right. Measures of central tendency, such as mean, mode, and median, can determine the skewness of a distribution. It is not the measure alone that tells us the skewness of a distribution. Rather, it is the relationship between the mean, median, and mode. Let us look at an example together. Here, we see the frequency distribution of age of students in a class. We can draw a histogram for this frequency distribution that looks like this. Remember, students, that to draw a histogram for continuous data, we locate the class boundaries along the x-axis. In this case, it is the age of the students. The width of the bar indicates the class interval, and the height of the bars indicate the frequency of each class. Next, by joining together points at the center of each class, we can draw the frequency curve. The curve appears to be symmetrical. Let us see if the mean, median, and mode support this skewness. To calculate the mean, median, and mode of the data, we first create this table. We have a column for the age distribution, a column for frequency, a column for distribution mean, and a column for the frequency times the mean. The mean is found by dividing the sum of Fm by the sum of the frequencies. Therefore, the mean is equal to 17.5. The median is the midpoint of the data. Since there are 5 classes, we can take the middle class, which means that the median is also 17.5. Mode, as you know, is the distribution mean that has the highest frequency. In this case, the mode is again 17.5. We can now conclude that whenever the mean equals the median and the mode, the distribution is symmetrical. If the mean is the largest in value and the median is larger than the mode but smaller than the mean, then the distribution is positively skewed. This means that the curve is skewed to the right. If the mean is the smallest in value and the median is larger than the mean but smaller than the mode, then the distribution is negatively skewed. This means that the curve is skewed to the left. Students, please calculate the mean, median, and mode for this data set. Predict the shape of the frequency curve, and then construct the curve to see if you were correct.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Let us compare our answers. To find the mean, we add all of the values together and divide by the number of integers. We get 45/9, which means that the mean of the data set is 5. To find the median, we arrange the dataset into numerical order. There are 9 integers, so the 5th integer will be the median. Therefore, the median is 5. The only number that appears more than once is the number 5. So, 5 is also the mode. Since we have found all the measures of central tendency to be equal, we know that the frequency curve should be symmetrical. When we construct our curve, we see that this is correct. If your curve looked like this one, well done. It is also possible to determine the skewness of a distribution by using measures of central tendencies and standard deviation. This is sometimes called a mathematical measure of skewness because it calculates a coefficient. There are 2 methods of finding a coefficient of skewness. The first method is called Pearson's coefficient of skewness. Pearson's coefficient is obtained by expressing the difference between the mean and the median relative to the standard deviation. It is usually denoted by the alpha symbol. If the mean and the median are the same, the frequency curve will be symmetrical. Using Pearson's coefficient of skewness, when alpha equals 0, the distribution is symmetrical. If alpha is greater than 0, the distribution is positively skewed. If alpha is less than 0, the distribution is negatively skewed. The second method of finding the coefficient is called Bowley's coefficient of skewness. Bowley's coefficient determines skewness by using quartiles, which are positional measures of central tendency. Bowley's coefficient is usually denoted by the beta symbol. The interpretation of Bowley's coefficient of skewness is the same as Pearson's in that if beta equals 0, the distribution is symmetrical. If beta is greater than 0, the distribution is positively skewed. If beta is less than 0, the distribution is negatively skewed. Let us look at one example of Bowley's coefficient of skewness. Here is a data set in ascending order. There are 6 numbers in this data set. So, to find the median, we take the average of the 3rd and 4th numbers. The median of the data is 8.5. To find the quartiles, we will use this formula. Please note this formula, students, as it will be used during the activity. Remember that K will be 1, 2, 3, or 4, depending on which quartile you are solving for. Also, N will be the number of integers in the dataset. Since we are solving for the first quartile, our value of K is 1. There are 6 integers in the dataset. So, the value of n is 6. We find that the first quartile will be the second item in our list, which is 6. To find the third quartile, we will use the same formula. This time, the value of k is 3. Since we are solving for the third quartile, we substitute the value for n, which is 6, and find that the third quartile will be the fifth item in our list, which is 12. Now we have the median and the first and third quartile, so we can use the equation to find Bowley's coefficient of skewness. Let us substitute the known values and solve the equation. We find the coefficient to be 1 over 6, which is greater than 0, so the distribution must be positively skewed. Students, now that you have seen an example, please use Bowley's coefficient of skewness to determine the skewness of the distribution for the following dataset. Remember to use the appropriate formulas for finding the quartiles. You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? Let us review the answer together. Our first step is to arrange the data in ascending order. The median will be the average of the 5th and 6th numbers. Since both numbers are 8, the median will be 8. Next, we take our formula for determining the quartiles. To find the first quartile, k equals 1 and n equals 10. By substitution, we find the first quartile to be the third item in our list, which is the number 5. To determine the third quartile, we change our value of k to 3. We determine that the third quartile will be the 8th item in the list. So, the third quartile is 14. We substitute these values into our equation for Bowley's coefficient of skewness. We get beta equals 14 plus 5 minus the product of 2 and 8 divided by 14 minus 5. This gives us 19 minus 16 over 9, which is 1 over 3. Therefore, the distribution is positively skewed. Great work, students! Today, you have learned how to use frequency curves to determine the dispersion of values of data. You have studied the relationship between the mean, median, and mode values as they relate to skewness of data distribution. You have learned how to calculate skewness using Pearson's and Bowley's equations for coefficients of skewness. That is all the time we have for today's lesson. Until next time, thank you, teacher. Thank you, students.